so high in the sky right now. Welcome back to another Austin World Physics problem where we'll be discussing gravity, that force that makes your fat jiggle downward. Now, our first equation is going to be the force of gravity equaling the gravity constant times mass of the planet times mass of Austin over the radius squared. Now plugging in these values, force of gravity, the G value is 6.67 times 10 to the negative 11. The mass of Earth is 4.87 times 10 to the 20th kilograms. And the mass of Austin is an insignificant 91 kilograms. Now the radius that we need to square is 6.05 times 10 to the 5th meters squared. Calculating that all out, we get force of gravity equaling 8.076 newtons. Now what we need to find is how high is the cloud world from the surface of Austin's initial world if the gravity is half of what it was originally. So 8.076 newtons, which is what we found, divide that by 2 gives us 4.038 newtons for cloud world. Now we're going to use that equation we had initially with 4.038 newtons equaling the force of gravity. So Fg equaling G m1 m2 over r squared. Let's just plug in these values and we get 4.038 newtons equaling the gravity constant as we had earlier times the mass of Earth once again. Multiply that once more by the mass of Austin. However, this time is an unknown radius. Now, multiplying that all out, and don't forget to do the square root at the bottom later, we're going to be getting 6.67 times 10 to the negative 11 times 4.87 times 10 to the 20th kilograms times the mass. Make sure you divide that all by the initial force of gravity, which is 4.038 newtons. Now, square root all of that, and the value we get is 855,588.5. Now, that's the radius from cloud world. What we're trying to find is how much higher it is. So we have to subtract the initial radius of Earth, which is 6.05 times 10 to the 5th meters, giving us the radius in between being 250,588.5 meters. Good job, ladies and gentlemen.